Hello. Today's practice is understanding this video's content and mm, if possible, I would like to try shadowing too. So far, I try to understand the each sentence meaning and for content meaning and try to shadowing. In the first part, from beginning and in the middle, maybe 2 minutes, 2 minutes mark, maybe. So from today, I'd like to second part. Mm, in the first part, this video explained about mm, how to store password in a database. Do not store password in the in plain text, and mm, uh, we have to do hashing, mm, and we have to use salt. Mm. It is the basic common. It is common rule um, organized by OWASP. OWASP is a Open Web Application Security Project. This organization made the rule to save the data for safety and security. Okay, let's dive right in second part.
Attacks. Some common attacks are rainbow tables and database-based lookups. With these techniques, a hacker could crack a password in seconds. By adding a salt that is unique to each password to the hashing process, it ensures that the hash is unique to each password.
This explanation is about how to learn the patterns of hashing um, hashing method. So only one times hashing is attackers can't expect the way to hash, but if the hacker try to read again and again, uh, maybe the hacker uh, can can predict to the way of hashing.
Seconds. By adding a salt that is unique to each password to the hashing process, it ensures that the hash is unique to each password. This simple technique makes pre-computation attacks.
So you have to use hashed password and salt. Salt? Salt is pepper and salt. Now, salt. Uh, can I confirm pronunciation of salt? Hello, ChatGPT. Could you tell me the correct pronunciation of salt? S-A-L-T.
Sure. The word salt is pronounced like salt, with a soft S sound at the beginning and rhyming with fault. The vowel sound is like the A in call.
Salt. salt, but my pronunciation is pepper and salt.
I get what you mean. Salt has a slightly different vowel sound from pepper. The A in salt is more like the aw sound, while pepper has a short E sound.
No, no,
With
no. Salt, sugar and salt is S-O-L-T, salt. But I want to pronounce S-A-L-T, salt. But I'm not sure about the difference of the salt and salt.
I see what you're saying. The difference between salt and sort is in the vowel sound.
No. Salt, sugar and salt.
Got it. You're talking about salt, as in the seasoning, like sugar and salt. The pronunciation of salt in that context is with an aw sound,
Ah,
similar to fault. It's not like sort, which has more of an or sound. So sugar and salt would have that aw
salt.
vowel in salt.
The spell of salt is S-A-L-T. So, I learned the salt's meaning. Salt has two another meaning. One meaning is a seasoning. Second meaning is mm, for security.
Exactly. Salt as a noun can refer to the seasoning you add to food, like sugar and salt. It also has a second meaning in the context of security, where salt is a random value added to passwords to enhance encryption. So you're right. Salt can have these two distinct meanings depending on the context.
Ah, I got it. So, I mistake. Mm, sugar and salt. This salt spells S-O-L-T, but I misunderstanding. Salt is S-A-L-T, and salt has two meaning. Seasoning and in context of the security. Next.
Unattractive. Let's take a look at how we store a password in Salt. We first combine the password provided by the user with the randomly generated salt.
The client, my user provided password, and salt is generated randomly.
We then compute the hash of this combination using an appropriate hashing function.
Password and salt we connect, and after that, hashing it.
The hash is stored in the database along with the salt. Again, the salt is used to generate a
After hashing, this is password plus salt. Hashing 1 is stored in a database hash column, and in addition, we store salt. We store salt in a database, another column.
unique hash. It is not a secret and can
It's not secret. So salt is a low text, right? Plain text. Salt and hashing password and salt stored.
be stored safely as plain text in the database. Finally, let's take a look at the process in reverse.
Let's take a look process.
When a user logs in, how do we validate the password against what is stored in the database? First, we fetch the salt.
How do we validate? How do we validate the password user entered against what we store in the database? What we store in the database and the password user entered. Validate. Validate means a check.
Salt for the user from the database. We then append the salt to the password provided by the user and hash it. We compare this computer hash against the hash stored.
One more time.
First, we fetch the salt for the user from the database.
We fetch the salt from the user, from the database. We fetch the salt. We get the salt from the database. Maybe the key is user ID, maybe.
First, we fetch the salt for the user from the database. We then append the salt to the password provided by the user and hash it.
The salt we get from the database. We can get the salt from the database, and we have a password. We connect them and hash it.
We compare this computer hash.
We compare this, and we can get a hash from the database.
Against the hash stored in the database. We compare this computer hash.
We can
against the hash stored in the database.
We can compare this hash and the hash from the database. We compare the hash against the hash, the one from the database.
If they are the same, the password is valid.
It's back.
That's it about storing passwords in the
database.
You would like to learn more?
I got it. That makes sense. And oh my god, I forgot to start stopwatch. Okay, 20 minutes. Start. So far, by the way, anyway.
Pre-computation attacks.
Yeah. From here, 2 minutes, 6 seconds.
Some common attacks are rainbow tables.
Some common attacks are rainbow tables.
Database-based
lookups. Rainbow tables. Some common attacks are rainbow tables and database-based lookups. What's mean? What does mean? What does that mean? What does it mean? Some common attacks are rainbow tables and database-based lookups.
Some common attacks are rainbow
tables
and database-based
lookups. B rainbow tables. Some common attacks are rainbow tables and database-based lookups. Maybe rainbow tables and database-based lookups is a name of attacks. Hi, ChatGPT. Could you tell me the rainbow tables and database-based lookups? This is a way of attacks?
Sure. A rainbow table is a pre-computed table of hash values used to crack hashed passwords. Instead of trying every possible password combination from scratch, attackers use these pre-computed tables to quickly find the original password that corresponds to a hash. This makes it faster to break passwords if they aren't salted. Database-based lookups refer to methods where attackers exploit a database to find matches or vulnerabilities. For example, if an attacker gains access to a database of hashed passwords, they can use various techniques like dictionary attacks, brute force, or rainbow tables to find the original passwords. Both methods are common ways attempt to compromise password security, which is why adding a salt to passwords is important. The salt makes each hash unique, making precomputed attacks like rainbow tables much less effective.
If I understood correctly, rainbow table is the type of attacks, and database-based lookups is different attack name. Is it correct?
Yes, that's correct. A rainbow table attack specifically refers to using a precomputed table of hash values to quickly crack passwords. On the other hand, database-based lookups are a broader category of attacks that involve exploiting a database to find or guess credentials using various methods, including but not limited to rainbow tables. So rainbow tables are one specific technique, while database-based lookups refer to a range of different attack strategies.
So database-based lookup is a wide concept of the attack, but rainbow table is one technique. How, could you tell me the rainbow tables?
Sure. Rainbow tables are a technique used to reverse cryptographic hash functions, primarily to crack hashed passwords. Here's how they work. Hashing basics. When a password is stored securely, it's usually converted into a hash, a fixed-length string of characters. This hash is very difficult to reverse.
Yeah.
Precomputed tables are rainbow tables, essentially a huge list of precomputed hash values for many possible passwords. By having these precomputed values, an attacker can quickly look up the hash and find the original password. Efficiency. This method saves time because the attacker doesn't have to compute the hash values on the fly. They just look up the hash in the table and find the corresponding plain text password. Countermeasures, adding a unique salt to each password before hashing makes rainbow table attacks much less effective because the same password will hash to different values when combined with different salts. In essence, rainbow tables exploit the fact that many people use common or simple passwords, and precomputing hashes for those can make it easier to crack them.
Ah, ah, a little I can understand. Pre-computed tables, rainbow tables mean a huge list of uh, pre-made, pre-computed hash values. So, uh, like a dictionary of the hashing value. So, you can validate pre-computed tables against the table the attacker wants to get data. So, uh, yeah, you can compare the rainbow table against the target table. Is it correct?
Yes, you've got the right idea. A rainbow table is essentially a dictionary of pre-computed hash values for many possible plaintext passwords. When an attacker obtains a hashed password, they can compare it against the pre-computed hashes in the rainbow table. If a match is found, the attacker can quickly determine the original plaintext password. So yes, the rainbow table allows attackers to compare the hash of a target password against their pre-computed list to find a match. This is why adding a unique salt to each stored password is so important to prevent this kind of attack.
I got it. Rainbow tables, and database-based lookups. This is technical knowledge. Rainbow table. And database-based lookup. Could you walk through database-based lookups very easy.
Of course. In simple terms, database-based lookups involve attackers using information they've obtained from a database, like hashed passwords or other sensitive data, and comparing it with known values or using various techniques to find matches. Essentially, they're searching through the data they've accessed to uncover useful information, like figuring out passwords or other credentials. It's like using the data from the database to find clues or break into accounts, which is why securing database information and adding layers of security is crucial.
So, attacker, uh, mm, attacker
An
tend
attack
attacker aimed to the database data. This is called database-based lookups, or database-based lookups is a attack name. Is it?
Database-based lookups isn't really a specific attack name. Instead, it describes a broad concept where attackers use data they've accessed from a database to find or exploit information. The actual attack could be
Broad
something like a
concept.
credential stuffing attack, SQL injection, or brute force attack, but the term database-based lookups just refers to the general idea of using the data in a database to find what they're looking for.
So database-based looks up is a broad concept where attackers use data they've accessed from the database to find out, exploit information. So this concept includes SQL injection and brute force attacks and rainbow table. The whole concept is a database-based lookup.
With these techniques, a hacker could crack a password in seconds.
With these techniques, a hacker could crack a password in seconds. I got it.
By adding a
By
salt
adding
that
a
is
salt
unique to
that
each
is
password
unique
to the hashing
to the
process,
hashing process.
it
Damn.
ensures that the hash is unique to each password, hashing process. By adding a salt that is unique to each password to the hashing process, it ensures that the hash is unique to each password.
My understanding is very slow.
Hashing process. By adding a
By adding
salt that
the
is
salt
unique to each password
unique each password
to the hashing
to
process,
the hashing
it
process.
ensures
It
that
is sure
the
that
hash is unique to each
hashing
password.
unique. I'm not sure about this sentence meaning.
Seconds. By adding a
By
salt that
adding
is
the salt, by adding the salt
unique to each password
to unique each password
to the hashing process,
to the hashing process,
it ensures that
it is sure that
the hash is
the
unique to
hash
each
is
password.
unique to each password. The hash is unique each password. By adding a salt that is unique to each password, to the hashing process, it ensures that the hash is unique to each password. By adding a salt, salt, not salt, salt. By adding a salt that is unique to each password, no, by adding a salt, not salt. By adding a salt that is unique to each password to the hashing process, it ensures that the hash is unique to each password. It ensures that the hash is unique The hash is unique to each password. Mm. Ah, without adding sort, each password is not unique because uh, uh, I'm not sure about this sentence meaning and this sentence structure. So, for example, by adding a sort that is unique to each password to the hashing process, it ensures that the hash is unique to each password.
No problem. Let's break it down. This sentence means that when you add a unique salt, a random value to each password before hashing it, the resulting hash is different even if the original passwords are the same. This ensures that every stored hash is unique, making it much harder for attackers to use precomputed tables, like rainbow tables, to crack passwords. In other words, by adding a unique salt to each password, even if two users have the same password, their hashes will look completely different, boosting security.
Ah, your explanation is very impressive. I got it. So, adding a unique sort to each password, by adding a unique sort to each password, even if two users have the same password, their hashes will look completely different. Okay, thank you.
You're welcome. I'm glad it makes sense now. If you have any more questions or need further clarification, feel free to ask anytime.
Uh, 5 minutes, only 5 minutes left. Okay, let's start speed up.
Hashing process. It ensures that
It
the
ensures
hash is
that the
unique
hash
to each
is
password.
unique to each password.
This simple
This simple
technique makes
technique makes
pre-computation
pre-computation
attacks
attacks
unattractive.
unattractive.
Let's take a
Let's
look at
take a
how
look
we store a
at how we
password in
store
Salt.
salt.
We first
We
combine the
first
password
combine the
provided by the
password
user
provided the
with the
user
random
with the randomly generated salt.
We then
We
compute
then
the
compute
hash
the
of this
hash of this
combination
combination
using an
using an
appropriate hashing
appropriate
function.
hashing
The
function.
hash is
The
stored
hash
in
is
the
stored in the
database
database
along with the
along
salt.
with salt.
Again, the salt
Again, the salt
is
is used
to generate a unique
generate
hash.
using
It is
hash.
not a
It is
secret
not
and
secret
can be
and can be
stored
stored
safely as plain
safely
text in the
as plain
database.
text in the database.
Finally,
Let's take a look at the process in reverse.
When a user
When
logs
your user logs
how do we
in,
validate
how
the
it
password against what
validates
is
the
stored in the
password
database?
against what we stored in the
First,
database?
we fetch the
We
salt
fetch the
for the
salt
user
for the
from the
user from the
database.
database.
We then
We
append the
then
salt
append
to the
salt
password
to the password
provided
provided by the
and
user
hash
and
it.
hash it.
We
We
compare
compare this
this
computed hash against the hash
stored
stored in the database.
If they
If
are
they
the
are the
same,
same, the password is valid.
That's it
That
about
is about
storing
storing
passwords
passwords
in
in
the
the
database.
database.
We would like to learn ensures that the hash is
The
unique to
hash
each
is unique to each password.
This simple
This simple
technique
technique makes pre-computation attacks unattractive. This simple technique makes pre-computation attacks unattractive. Pre-computation attack. This is using rainbow tables and database-based lookups. Unattractive. Let's take a look at how we store a password in a salt.
Let's take a look at how we store a password in Salt.
With a sort. With a sort. Let's take a look how we store a password with a sort.
We first
We
combine
first
the
combine the
password
password provided by
with the
user with a randomly generated sort. Sort. All sort translated to salt.
We then compute the hash
We
of
then
this
compute the
combination
hash of this
using an
combination using an
appropriate
appropriate hashing function. We then compute the hash of this combination using an appropriate hashing function.
The hash
The
is
hash
stored
is
in the
stored in the
database
database along with the sort. Along with the sort.
Again, the sort
Again,
is
sort
used
is
to
used
generate
to
a
generate the
unique
unique hash. Again, sort is used to generate the using hash.
It is
It
not
is
a
not a
secret
secret
and can be
stored
safely as plain
safely
text in the
as
database.
plain text in the database.
Finally, let's take a look at the process
the
in reverse.
process in reverse.
When a user logs
When the
in,
user logs in,
how do we
validate
validate the
the
password against what is stored in the database?
stored in use database?
First, we fetch the
we
sort
fetch
for
the
the user
sort. We fetch the sort for the
from the database.
user from the database.
We then append the sort to the
password
password provided by the user
and hash it.
We compare this
We
computer
compare
hash
this computer
against
hash against the hash stored in the database.
If they are
If
the
they're
same, the
password is valid.
That's it
That
about
is about
storing
storing
passwords
password
in
in
the
the
database.
database.
Let's take a look at how we
Let's take a
store a
look at
password
how
in
we
sort.
password sort.
We first
We
combine
first
the
combine the
password
password provided by the user
with the randomly
with the
generated
randomly
sort.
generated sort. We first combine the
password provided by the user with the randomly generated
sort. Combine A with B. Is a connect. We first combine the password.
First combine the password
provided by the user with the randomly generated sort.
by the user with the randomly
With the randomly
generated
generated sort,
We then compute the
hash of this combination
using an appropriate
an
hashing function.
appropriate
Compute the
compute
hash
the
of this
hash of this
combination
combination
using an
using the
appropriate hashing function.
hashing
The
function.
hash is stored in the
Hash is
database
stored in
along with the
database
sort.
along with sort. The hash is stored in the database along with sort. Maybe along with mean next to and very near to. Time up. Okay. Today I'd like to wrap up. Let's wrap up. So yeah. Tomorrow I'm gonna keep. I'm gonna keep. How do I say 頑張る try hard? Try hard or keep in mind? How can I say try hard different phrase?
You can say put in a lot of effort, give it your all, go all out, do your best, or strive diligently. Each of these phrases conveys the idea of trying hard in different ways.
Putting a lot of effort. Putting a lot of effort. Give it your all. Give it your all. Go all out. Do your best. Strive diligently. Strive diligently. Putting a lot of effort. Putting a lot of effort. Okay, let's put in a lot of effort tomorrow. See you next time. Bye.